Today we're going to be going over area and volume. Now this is worth 42 points on your average SAT, so a very big concept, definitely know these. Our approach on these is going to be to identify area and volume questions. We're going to break down the question, we're going to build a formula to solve them, and then lastly we're going to solve a practice question together. So how do you identify these? Well, these questions will test area and volume formulas. Now, many of these can be found on the embedded math formula sheet, which you can actually see right here. So this sheet is given to you on the SAT and has an assortment of volume and area formulas. Most of the ones you're going to need to know on the test are actually on here, and so I wouldn't spend too much time memorizing them, but it is possible you get one that's not on here, but not very likely. So here's the formula we're going to follow. We're going to identify the shape we have, we're going to decide the correct formula, and then we're going to use our formula to find the answer. So here's an example. A cylindrical tank has a radius of 6 feet and a height of 10 feet. What is the volume of water in the tank if it is filled up to 3/4 of its capacity? Well, we're going to identify our shape, and our shape is a cylindrical tank, and so I think that's going to look something like that. No, not an artist, but a cylindrical tank will look something like that. And so let's look at the formula of the shape that looks like that. So it's looking like this one to me. So volume equals pi r squared height. Pi r squared height. Okay, perfect. So now let's plug into our equation the values we know. Radius of 6 feet. So 6 squared and a height of 10 feet, 10. So I'm getting a volume of 360 pi. Now it's really tempting to look at the answer choices. On this one, they actually don't even give us 360 pi as an answer choice, but they typically do. And so if you were moving quick, you could have easily picked that one, although it is incorrect. And the reason it's incorrect is because we are only filling this 3/4 of its capacity. And so we actually have to multiply this by 3/4 or 0.75, whichever you like, which is going to give us 270 pi cubic feet, which is going to be answer choice A. So on these, it's very much just knowing your formula and knowing how to plug in. Another thing I'm going to mention that they can sometimes do is they'll give you volume and they'll give you something like height in this example, and they'll ask you to solve for radius. And so you'll kind of have to work backwards from your formula, but these ones are pretty straightforward of getting the formula and then applying it to the question. Lastly, make sure you read for things like this, the 3/4 of its capacity, because they're going to try to trick you on these since there's not that much complexity. They'll try to add their own complexity in ways like that. So this one isn't going to be the most useful Desmos use case, but sometimes it can be useful, so keep it in the back of your mind. Good luck on these.